Hello, my name is Steven Sober, and I am part of the global technology practice at SAS. My super demo is based on the SAS Global Forum paper that I and Brian Kennebrew co-authored. The paper title is Best Practices in Converting SAS Code to Leverage SAS Cloud Analytic Services, which we refer to as CAS. CAS is the in-memory engine for SAS Viya. This super demo has three components. First, we'll review the GitHub repository of the code I will be demoing. Secondly, I will run a few examples from the repository using SAS Studio. Lastly, I will share with you information on the SAS Viya readiness utility. Let's get started. The GitHub repository can be found at this address. This address is documented in our SAS Global Forum paper. Once you go to this address, please take time to read the README file. There's some important information. For example, all of the programming examples are for functional testing, not performance testing. Also, this is the required step that all of the other coding examples are dependent upon. This step simply sets a path to a macro variable I call data path. Once you run the setup step, then you can run any of the additional coding examples in any sequence you want to. To clone the repository, what you need to do is to back up in the tree structure to the SAS Global Forum 2020 level, as you can see here. Then notice you have a clone or download button over here in green. When you clone it, you actually have access to any of the SAS Global Forum papers where the author has chosen, like me, to create a GitHub repository. To demo a few of the programs located in the GitHub repository, I will be using SAS Studio 5.2. SAS Studio 5.2 comes with SAS Viya 3.5. One of my favorite features of SAS Studio 5.2 is the GitHub integration. More about that later. First, we will run the setup program, which defines the macro variable data path. The macro variable data path must point to a path that your SAS Viya environment has access to. Once the setup job completes successfully, then we can run any of the other programs in any sequence. As we can see by looking at the errors, we have 0, which means our job ran successfully and our data path macro has been defined. Let's take a look at a program that will convert all character data types with a length of 16 or greater into varchar data types. The reason one would want to do this conversion is because CAS data is closely coupled with its memory representation and requires alignment to 8-byte boundaries for memory mapping. That means all variable lengths must be a multiple of 8, and that means record lengths and data sizes will increase when lifting data into CAS. To accomplish this, we will leverage the procedure CAS util, and specifically the statement varchar conversion. Notice we have set that variable to a length of 16. When we look at the data step that generates the source data to be lifted into our CAS table, we notice we have a length statement, and for variable A, it has a length of 300. Variable B has a length of 15. Variable C has a length of 16. Notice we're creating 3 output records where the values of each of the variables vary in length. Let's go ahead and run this code and then look at the result window. In the result window, we can now see the data structure of our CAS table. And sure enough, for all variables that were 16 or greater, we've converted them to varchar. And notice on variable A, we have a varchar length of 135. That's because the longest value in the source table for variable A was 135 in length. The next program we will look at will parallel load and compress a CAS table. To accomplish this, we will use the procedure CAS. The statement that parallel loads and compresses the CAS table is the index statement. The index statement of the procedure CAS always runs in parallel. Now, the important options on the index statement is the compress equals true statement, which simply means we will compress the CAS table, and the single pass equals true statement. The single pass equals true option means each thread will load a record and it will also compress that record. The default value for single pass is false. That means the CAS table will be loaded first, and then in a second step, we will compress the loaded CAS table. Customers have reported back to me that this technique has improved runtimes of loading CAS tables. When we review the SAS log, we will see our compression ratio. By reviewing the log, we can now see what our compression ratio is. In this instance, it was a compression ratio of 5. Here's the original data size, and then the compressed data size. Next, let's review the GitHub integration that comes with SAS Studio 5.2. For example, let's say we wanted to add a statement here, which will display the value of our macro variable data path. Let's run the program. And as we can see in the SAS log on line 92, we have our new put statement, and right underneath it, the actual value of the macro variable data path. I'm happy with that change. Let's save our program. Now that we've saved the program, using the interface to GitHub, I notice I have one change to my GitHub repository. If I click on it, we will see what the change is. Well, here, notice I've added a new statement in green, %put at data path. Yep, I'm happy with this change. The next thing we want to do is to stage this program and add a comment before we push it back to our GitHub repository. To do that, simply click on this, and now you'll notice in the staged area, we have our program. I'm going to add a comment. That way, when we push our change back to the master, they can decide if they want to merge that change into the actual repository. So, a very simple comment. Now we'll commit our change. So this will refresh the interface, and notice up here on Pushmaster, we have one change. So let's go ahead and click on it. And now we've actually pushed that change to our GitHub repository. And if we go into the history here, we can see that we've added a put statement. And sure enough, here's my change, added a put statement. And if I click on my setup program, we now have in our GitHub repository the new changes to our program. We covered quite a few things in the demo. Let's refresh our memory. Remember, for the setup.sas program, you must run this program before you run any of the other programs in the GitHub repository. It's line 10 you need to modify so the macro variable data path points to a path that SAS Viya has access to. With the how to convert character data types into varchar data types when lifting a CAS table into CAS. As you can see on line 43, it is the varchar conversion statement that allows us to convert all of the character data from a source table into a CAS table. And when we reviewed the results after running, we validated the variables that were 16 or greater have been converted to varchar. With the how to parallel load and compress a CAS table, the important statement begins on line 27, the index statement. Again, index will always run in parallel on all threads of all CAS worker nodes. The next important statement is on line 28. Single pass equals true. That means in one pass of loading that CAS table, we will have a compressed CAS table. And then on line 29, it's the compress equals true that tells the CAS procedure to compress the table we're loading into CAS. When we ran that program and reviewed the SAS log, we saw the original data size, the compressed data size, and the ratio of that compression. Now I'd like to shift gears and give you some information on the SAS Viya Readiness Assessment utility from SAS. The utility does not execute any code ran through the utility. It simply scans each word and scores that word based on it being CAS enabled or not. You point the utility to a given directory, and then the utility will parse all files with an extension of .sas in that directory, as well as all subdirectories of that path. You have two options. The most popular is SAS will come on site with the utility and work with you to install it, configure it, run it, and then explain the findings. The second option would be you would send your code to SAS. We would run it through the utility and then schedule time to present our findings. Whichever option you want to use, simply ask your SAS account team to contact myself, Stephen Sober, or my colleague, Brian Kinnerbrew, and we will assist the SAS team to run the utility against your code. We're going to review a couple of the reports produced by the utility. This is the frequency report. And we can see in the frequency report, we ran the utility against 1,501 SAS jobs. And those jobs are actually from the sample programs that are delivered with SAS Foundation from Base, Core, our ETS product, and our STAT product. The next thing to notice are the procedures that are CAS enabled. That means these procedures will run in CAS provided the source data and the target data to the procedure are CAS tables. The next thing to notice is candidate for CAS, like for data step and these analytical procedures and proc append. Candidate means you might be able to refactor the code for the procedures into a CAS-enabled procedure, or you could study CASL, the language of CAS, and run your code as CASL code. Regardless of which way you want to go, you may be able to convert a lot of procedures you use to run in CAS. Now with data step, the majority of code is CAS enabled, but there are certain functions and formats that are not supported, and the utility will point those statements out to us. Also, for a lot of the procedures, not all of them, we have mapping suggestions. So look down here at this one, proc logistic. Proc logistic only runs on the SAS Viya compute server. You can refactor that code to the procedure proc log select, and it will run in CAS provided the source and target tables are in CAS. In addition to the frequency report, there's the detail reports. For each program you run through the utility, you will have a file. Let's look at one of these files. The name of the program we're looking at is up here on line 1. For the flags column, to understand the flag, review line 3. The way I use this report is by focusing on the restriction column. And anytime you see the word CAS, that means it's found a statement that will not run in CAS. The key word will give you a hint on what the actual statement is. This is an example of a title statement, and it only runs in SAS Viya's compute server. If we scan down here to logistic, it got flagged as well because that only runs in the compute server. But we know, based upon the frequency report, we can refactor that code into log select, and that will run in CAS. Thank you for attending my super demo.